This jigsaw started with a 0-degree drilling angle. They did a fun trick layout on this one just because they could. And then they actually ended up at 30. So we're looking at 30 degrees difference, which can produce a difference in ball motion from which we're actually expecting. And this blue Vibe started at 50 degrees drilling angle, and based on once we actually drilled it with the holes in it, the PSA shifted, giving us a 30-degree drilling angle. Any other questions about the before and after layout thing? Okay. So now we're going to go to we're actually going to go to the lanes. So a lot of that stuff done on the pro shop or done off the side. We need the terminator present, so most likely in a pro shop. But go ahead and you can clean all the drawings that you've done on the ball. You clean those off, but leave the PSA marks because you're going to need that for later. Have your bowler establish a line to the pocket, warm up, get ready, and once they're ready to go, have them establish a line to the pocket. And when we're ready to throw that data collection shot, take the ball, and we're going to clean it really quick, use a cleaner, and also the other thing we like to do is not to change the surface of the ball, but to make data collection a little bit easier, is to take a really old Avalon pad, you know, those ones that are sitting in the corner of the shop that you're just not using because they're not giving you the grit you want anymore.
And for some reason, nobody threw them away.
Right. They're still sitting there. The ones that aren't working the greatest, take one of those and quickly go over the track area of the ball, just real lightly because you're not looking to change anything. It'll make seeing the oil rings of the track flare a heck of a lot easier when that ball comes back. Have your bowler throw a shot. And when they're doing that, you can want to record the location of the ball at the laydown, at the arrows, and at the break point. So that's all this ball path information here. The interesting part about doing it this way is you can take this ball path information and compare it to your spin time. Your spin time gives you an indication of the strength of the core of the bowling ball, and the ball path information is now giving you an indication of the total hook of the ball, or the strength of the cover stock of the ball. So if you potentially would subtract those two, I realize they're not in the same units, but if you look at them at a scalar value and subtract those two, you're getting more of a total hook idea, and you can understand more cover stock strength, which also is very difficult to do in the field. So the other thing that I like to do is I like to have the bowler tell me the location of the ball at the arrows. It's very difficult to watch the laydown location and catch the arrows for the individual doing the data collection. If you can catch all three, great, but I think it's helpful to communicate with your athlete and really make sure you're getting the same information. So go ahead and grab the ball from the ball return, and we're going to quickly trace the first oil ring of the track flare. And when I mean quickly, I mean like we could underline this, bold this, etc. Grab the ball as soon as you can and get that first oil ring. They go away really quickly on today's cover stocks. So if you end up repeating it, you're talking about re-cleaning the ball, grabbing that Avalon pad and giving it a quick dusting on the surface. It's a little bit of a pain. So quickly trace the entire first oil ring of the track flare. Then you're also going to trace the last oil ring of the track flare and the last dry flare ring. So you'll see a bunch of oil lines on your bowling ball. You'll also see a bunch of lines on your bowling ball that do not have oil on them, but they're from the ball rolling in the dry part of the lane, which is particularly helpful if you gave it that little bit of a surface to grab with right off the bat. And then you want to trace those. So here is another example, Powerhouse Blueprint. This is a 715C, got it. And we threw it on Sol. So Powerhouse Blueprint allows you to actually demo the balls, and it'll give you the track flare as well. So there's the first oil ring first track flare ring in the oil. There's the last one in the oil, and that's the last one in the dry. The dotted ones are the ones in the dry.
So when you're grabbing that last one, if you haven't done this before, it's a little hard to see, and it takes a little bit of practice. If you've done it and you really look at the ball, you can see where the ball hits the pin, or the ball hits the head pins. And Anybody ever seen that before? I know some of you have. I've seen that heads shaking, nodding. So if you can see that, really, I'm like, if I see that, I'm golden, because I know that's where that last ring is. And then the two oil, the first oil ring, the last ring in the oil, those are usually pretty easy. It's really just that last one that I struggle with, but that one stays on the ball longest, so you want to grab those other two first, and then start looking for where the ball hit the pin, or the last ring you can see, just trace.
So what we're going to do with these flare rings that we've traced, the first one you're going to do is you're going to grab the axis tilt measurement using the very first flare ring.
Using a ProSet, measure the distance from one side of the first oil ring to the other. A ball with 0 degrees of axis tilt should have a distance of 13.5 inches. Using the axis tilt table, find the bowler's axis tilt in degrees.
Back of your handout. Last page of your handout. I think this has been talked about in a couple other sections. So here you have it. There it is.
So that's how you actually measure axis tilt. Rod and the IQRC have it labeled on their armadillo as to which ring on the armadillo actually matches up with what degree of axis tilt. Rod, you want to talk about that a little bit more, or? Sorry. I think it's cool. We just always take the measurement. So I mean, you guys are looking for efficiency. I'm standing there data collecting all day.
We're trying to do it fast. And actually, that chart on the back of your pamphlet there tells you degrees of axis tilt. Actually, you can line up to the lines on our armadillo as well. And when you look at them, you go across. We just labeled it so we can actually, when we see those oil rings match up, we know whether it's 10 degrees or 17 degrees or 3 degrees, or if you're splitting in between the oil lines. So it's a little quicker way to actually, once we found that oil line, that PAP is accurate to actually get the tilt recorded, because tilt's virtually impossible to record off a video camera to be able to get a good idea of what the tilt is. But the track will tell you exactly what that tilt was. So if you have an armadillo, this is a nice little trick, and it makes you speed things up.
Any questions on axis tilt real quick?
One of the simplest methods for finding your PAP is using an armadillo device.
Okay, so the next thing we're going to do is start. So we have axis tilt here on your form. Now we're going to do the PAP at release, at the break point, and at the pins. So the release is the first oil ring, right? That's the release, the first oil ring you got when you threw the ball. At the break point, what we use is the last oil ring. Now, is that perfect for your break point? No. Is it closer to any other measurement you have right now? Yes. That's what we use. And then PAP at the pins, like I said, if you can see that spot where it hit the pins, and that's that last oil ring right there, that's your PAP at the pins. I think in which class we talked about, axis migration, your path moves, and then this is a direct measurement of that. It's kind of cool.
One of the simplest methods for finding your PAP is using an armadillo device. To find your positive axis point at release, use the trace line of your first oil ring and place the armadillo on the bowling ball. Mark the location of your axis. Mark your grip center line. Find your grip center by finding the equidistant point between the front cut of your finger holes and the front cut of your thumb or thumb slug. If you're using an interchangeable thumb slug device, measure from the front edge of your inner slug. For additional clarification, please see page 1-5 of the equipment specs manual. Draw a perpendicular line from your grip center towards the side of the ball with no track lines. Draw a line perpendicular to the line you've just drawn that goes through the marked axis point found from the armadillo. This line will be your vertical axis line, or VA. Measure both the distance from grip center to GAL and the distance from the intersection of those lines to the actual marked PAP at release. For example, if your access length line is 5 inches long and the actual marked PAP is 3/4 of an inch above the intersection, your PAP is 5 inches by 3/4 inch up. To find the positive axis point at the break point, use the last oil ring and match a line on the armadillo with that track flipper. Repeat steps 2 through 7 to find your PAP at the break point.
2 through 7 don't entirely.
To find the positive axis point at the pins, use the last dry track ring and match a line on the armadillo with that track flipper. Repeat steps 2 through 7 to find your PAP at the pins.
Yeah, when he's talking about 2 through 7, there was this very, very lengthy written out instruction form, similar to what you have, but it was even more detailed. If you're interested in that and you need the absolute VCR step-by-step instructions, we can get it to you. But really, I think the video is so much easier now to see what's going on.
All right, very good. So that's finding the path. I showed you finding the path at release. You would do the same thing for the other 2 oil lines, and then you have your 3 path measurements, which we'll show some examples of that in 1 second. So yeah, we'll go to the next one, which is gonna show you that oil migration. So axis migration.
Be sure you still have all 3 of your positive access points marked: PAP at release, breakpoint, and the pins. Using a 6-inch metal ruler, measure the distance from your PAP at release to the PAP at the breakpoint. This will tell you the axis migration in oil. Measure the distance from your PAP at the breakpoint to your PAP at the pins. This will give you your axis migration in dry. Measure the distance from your PAP at release to your PAP at the pins. This will give you the total axis migration. Sketch a picture of the 3 axis points and the corresponding axis migration lines.
All right, so that would go here down at the bottom. So you got axis migration in the oil, axis migration in the dry. Add those 2 together, and that's essentially your total migration. We have several examples coming up. And then it talked about drawing a picture. You can draw a picture towards the bottom of the form. One thing that we've started doing, and I now recommend, is take a picture of each one. And Nikki talked about making sure that it's, Nikki and I talked separately about making sure that you label that photo. You could label it something like, Prolane, short, blue vibe. And in that way, now you know, here's your axis migration, you have your numbers, so this could be your picture, and if you label that Prolane short blue vibe, you know right away that's wrong, because it's not blue vibe. But you know what that is. And it almost, if you get good at this, you don't need the form anymore, you just need the pictures. You can pull them out in front of you. Here's what we did on short, and here's what my axis migration looked like with this ball on short. You probably want to put maybe 1,000, and maybe you want to simplify it like PL 35, blue vibe 1,000. So Prolane 35 feet, blue vibe 1,000 grip. And then you have this picture with that title, and all of a sudden that's everything you need. You don't really need the form. You don't need to handle all these forms anymore. You just pull up your iPad and pull out the pictures for each bowler. Have this under a folder for each bowler, and you're good to go. Does that make sense? Making sense? So this shows, for example, this is going to be your axis migration in the oil, because this path would have came off of the first oil ring, and this one would have came off the last oil ring. So in the oil, it's only migrated 1.5 inches, whereas in the dry, it migrated 2 1/4. So you can see where it's flaring. You can see that ball and where it's flaring. And that starts to give you a picture of what's going on. All right, so it gives you a picture picture what's going on. You can start to do some trends for comparison. Like I said, I would also do it for short, medium, and long, because you're going to get different results, especially comparing short to long, especially some of the short patterns we have in WTBA. But in general, if it's like the example we had here, this is 1.5 in the oil and 2 1/4 in the dry. So it's longer in the dry. It's going to tend to be a cover dominant kind of ball.
Yeah, we sanded that ball. That ball is that's pretty rough. I mean, I believe that one, the one in the photo is at 500 grit. But we really wanted to make sure that
You
it
see it.
photographed well.
The other thing then is the shape. Now that axis migration on that particular ball that I was just showing is pretty linear. It's pretty straight. So that is going to be more of a ball that tends to be more even arcing, even reacting. And obviously if it has larger curve to it, it's going to be something that's transitioning quicker. Does that make sense? Everybody see that and agree with that? All right, Saul, I think you go through a handful of examples that we've done.
So the neat part about working with where we do is I have a few very, very talented bowlers at my disposal to ask to help me be guinea pigs. This person threw this bowling ball at its starting surface. We called it 1000 Grit with Lane Shine. It had been used for a while during league, so it wasn't at its original starting surface. So that's where we wanted to get a baseline and see what happened. The axis migration in the dry was 2.875 inches, and in the oil is 1.5 inches. Again, we're talking about a little bit more cover dominance. So we did, just to see what would happen, is we sanded it to 1000 grit by hand. Here's what we wanted to have you guys take away is I think a lot of times in competition, you're gonna that will be what you have out there. You'll have the sanding pads and you can adjust surfaces by hand. So we wanted to see what happens as you change some of that stuff. And then we ended up with a little bit more even axis migration, and it smoothed out the ball. But sometimes I think ball motion is really difficult for people to see. So the nice part about this is it quantifies, and I actually put some numbers to it. So you can say, of course, adding more surface to it is going to smooth it out. But some people don't get it right off the bat, so adding the measurements and things to that and the axis migration pictures to it as well helps hit some of that home a little bit more. Here's another example. Starting surface, I want to make a quick note before I show you what we did to it. If you look at the shape of this axis migration, relatively similar on the starting surface ball to the second one. This is this particular bowler's benchmark ball. They really like that. That's the one I would play with like crazy and make it do a bunch of different stuff. I would take it up, I would take it down, do analysis on the surface because this is the one they like. So this is the one that they're going to go to and it's going to get them out of trouble in situations on long, short, it doesn't matter. They're probably going to try this ball no matter what. So if you play around with it, really get a big database of different things that can happen when you change the surfaces on that ball, they'll be able to make decisions quickly on it.
And also be able to understand what they like about it.
So we sanded it to 500 grit by hand, evened it out a lot, but we were, again, your axis migration in the oil is very short, and in the dry is also short, but the comparison between the two is the key part. Definitely cover dominant because we sanded it to 500 grit. But you can see how the shape itself shifts and we're getting a different motion on the lane as well. This is that same bowler again. We're getting this particular ball. It's not that they don't like this ball, but they find it to be a challenge in a lot of different situations. If you go back to the other two, it has a different starting axis migration shape than either of the previous two. So one thing to consider is that, this particular axis migration shape right here, this trend, may be something that bowler's eye really catches on to, and it could be something that you're going to want to maybe try try to grab on each one of their balls, if you can make it look more like this, yet still match up on conditions, and it may be more preferable to that bowler. Not 100% certain, variety is always helpful, but it's just something to consider as well. Maybe there is something to that shape that works well for that bowler. So this ball itself tends to have a very, very strong cover stock in general. The axis migration in the dry was 1.3 versus in the oil 2.3. So you would say that this is more core dominant at that point, but they shined it, so this one is like 4,000 grit and shiny. So they took a ball out of the box that was really strong cover and shined it to bring it down, but it kind of is not matching up and it's not giving as much of desired results as they would like. But what we did just to see if we could do something for fun is we took a 4,000 grit pad by hand and wanted to see what minute, like, can we make small changes and still get results from axis migration. And here we can see there is a difference in not only the axis migration in both the oil and the dry, but the shape changed slightly too. So the neat part about this is you can quantify very, very small changes in ball motion. And really that's what we're looking for. I mean, bowling is a game of millimeters. I can't even say a game of inches because an inch is too big. And micrometers is probably even better. But bowling is a game of very, very small adjustments, and whatever you can do to get that advantage and document that advantage so you know what it is, you're going to be better off for your bowler. The last one, we talk a lot about surface because I think that's the thing that you can play with the most when you're out in the field, is an example of a ball. Here we have here's the axis migration. This is a different bowler, by the way, as well. Here's the axis migration that we started with. They weren't a huge fan of it. They were like, hey, it's okay. And we're like, well, why don't you put a hole in it? Why don't you add a balance hole to it? Oh, okay. They didn't like it to begin with, so why not try something? And look at the difference in axis migration when we add that balance hole. We definitely saw a difference in ball motion overall, but as well you're getting this different axis migration, we can quantify what exactly happened. And it changed the motion entirely, and it was much more satisfactory to that particular bowler, so it helped them out a lot.
So what I see from all of this, and what I see WTBA coaches, you have the ability to change surface in between games. This is something that I think would benefit you to be able to know ahead of time and understand ahead of time what you can achieve, what you want to achieve. Anybody else that's not, anybody in the U.S. or in other competition where you can't make those adjustments in between games, it still is beneficial because you're going to have practice. And how much time do you have in practice? Usually not as much as you want if you're lost. When you're lost, it goes by way too fast. When you're bowling good, everything, you don't need that time, or it can't go fast enough. So if things aren't going well, this gives you, maybe one or two times to mess with a couple of balls and get them to fit and get them to work. So what I like to do with this, and we've kind of glossed over it, is take short, medium, and long. Let's just talk about medium. Take your benchmark balls and the full arsenal, what you think you're going to take to a competition. And maybe it's 5 balls, maybe it's 6. But run this through for those balls. Then take a look at it. Why is this the benchmark ball? You'll start to understand if you got 2 or 3 benchmark balls that you really like in certain situations, you'll start to see some similarities and understand it a little bit better. And then when you've got something like the previous slide, here, where it wasn't a favorite ball, it was like
It was very condition specific.
Exactly, a weird scenario, like I might pull this out if such and such happens. Well, you'll be able to pull that out too and be like, well, that makes sense because this doesn't match this, it's nowhere near that. And you can start to take a ball like this and not necessarily match it with one of the benchmark balls, but fill the gaps. So So you got 5 or 6 balls, and you've got, okay, for this, and breakdown, and, you know, fresh, and usually you've got a little bit of a game plan, but if you can take these other balls and fit them in, and now all of a sudden they can actually be valuable to you. You can fit in between games. Or the times, you know, you hit that transition, you're here, you lost it, you're not quite here, and now you got that ball that fits in the middle. It's also great to know that if you're going to, say, a WTBA competition and you're bowling on, you know, short and medium, or especially short and long, you've only got 6 balls. You've only got 6 balls. If you got a spare ball, you only got 5. Well, if 2 are for short and 2 are for long, you know, what's that other one going to be for? Well, it kind of depends on the bowler and the coach and what they think they need to try to do. But if you can learn what to do to the ball to get it from here to here, 1 or 2 of those balls, based on your surface, can go from short or long, or medium to long is probably a better example. Does that make sense? But it takes that work, it takes that time ahead of time. But it really gives you the opportunity to understand what's going on, why this bowler loves this ball, why this bowler loves this ball, and when you go this direction, that bowler gets lost, etc. You're all coaches, you know what I'm talking about. So I rambled on long enough, and we're at a point where if anybody has any thoughts, questions, examples, we'd love to hear them.
I do have a question regarding pads, sand pads.
Yes.
With the research you've done, how long do they last? And does a rough grit pad then become a smoother pad?
We've done, I'll say, research on 2 levels. And of course, the level that we spent the most time is the one that's not as applicable to everybody in this room. Unfortunately. But that was because as we do the surface roughness testing, it's one of our specifications we do on all bowling balls, we learned that a fresh pad is more consistent on every ball. And as you go from ball number 2, 3, 4, and 5, it was fairly significant from a specification standpoint. If we were to set a spec on surface roughness like we did, and expect the first ball on a pad and the 5th ball on a pad to give us the same baseline, it wasn't going to work, it wasn't going to make sense. Let me back up a little bit. When we're doing surface roughness, we take every ball to that same surface. We use 1,000, 500. We did 1,000 in our ball motion study. We use 500, and the fact that they're all at 500 grit, the reason why the surface roughness is different is because of the chemistry of the ball. So the fact that we get different readings off of all balls being at 500 grits is due to the chemistry. Porosity might be a better kind of understanding for people to see it. And so we use, one pad, and we get different values, but that's why we get different values. And then if we were to keep using that pad, we would get different values, and it wouldn't be because of the chemistry, it'd be because we're using used pads. So we actually use 1 ball per pad. Per ball.
We
One
sand,
pad per ball.
We sand 2 balls per pad.
2. Thank you for correcting.
No, it's okay. What we do is, so we get 2 samples of every ball in for approval, and they go into, we use the Storm Surface Factory to give us the most consistent surface. The 15-pound ball gets sanded first, and then the 14-pound ball gets sanded after that on the same pad. If we sand them in reverse, we tend to get about even numbers between the two weighted balls based on the fact that the Surface Factory is gravity driven. However, that all being said, that doesn't exactly address your question, because that's what we do for testing, and that's not what you're looking for in the real world.
Yeah, so what I was trying to say, and of course I backed up and went way too long, but is for true high-level comparisons, we end up using 1 pad
Pretty much one and done.
per brand of ball.
Yeah.
So it's kind of what
It's a one and done type deal.
15-pound ball and 14-pound ball, which we get for testing. We use 1 pad, and we're done. And that way, we know, and we've studied that that's all you can do. So I don't know of any coach that's in that area.
But does
position,
that
realm.
500 pad then become an 800 pad as it starts to lose its effectiveness?
We don't, yeah, we haven't done the direct correlation of that. Have you, has anybody else done it?
But is there no actual testing of the Avalon pads and whatnot? I mean,
It's
on your guys' end?
standard from the supplier.
We can tell when something's changed.
Yeah.
And we tried to do surface roughness on an Avalon pad, and it's a difficult thing. You have,
I happen to be a product specialist for the company who's making those. And what we have tested is we recommend maximum four balls. Then the roughness is going to be 2 different from the original. Okay, it depends again whether you're using a spinner, you sand it by hand, or you sand it with the machine. The more revolutions, the sooner the pads wore out. If you use by hand, you can basically do 10 balls by hand and still have close to the same roughness. But then again, when you're using a machine, especially on the higher grits, the sooner the pads are losing the roughness. Basically, if you're using spinner, four balls, you get still close enough.
Okay.
But if you use use
Dividing in
I would say
10. Spinner or something power operated.
Oh, we will actually produce to the market. We started to sell in Europe last week a new sanding machine. If you want, I'll show you a video of it, but that's a different story.
Go ahead.
It will be safe here beginning next year.
I can also say with using the surface scanner, the laser,
Yeah.
that once my 2000 pads start to show visual wear, that actually reads more at about 3000 on the surface.
So it is okay to transition them down, is what you're saying?
Yeah, I mean, now of course, usually I use a white 3M pad for 3000. I found that to be a little more accurate, but they do tend to go up. But according to the surface scanner, which is not quite as accurate as what you guys use.
It's an excellent question where if you want to, perform some of the activities we talked about and then be able to repeat them, you want to make sure, you're within 10 balls. You start getting past that, now you're trying to repeat something out in the field, and you're exactly right. You're not going to quite get that same result if you held onto that pad for, 12 months and 1,500 balls. But thank you, thanks for the extra info. Yeah, Del.
A few years ago, when Evan and I came out with this, they said that if you used a lot more water, you would get some longevity out of the pads. So me being me, I went and tested it, and as far as I could tell, I could get about 2 more balls out of it and still hold some of the integrity of the pad. But you can't just use like a little spray bottle and use a little bit of water. You really had to use a lot of water.
And soak that pad over.
Yeah.
All right, good question. Anything else?
On the Terminator, on the spin time, you said the faster is closer to asymmetrical, the slower, more towards symmetrical. What are we talking about in numbers here? Like faster or slower, how many seconds or tens of seconds?
I've seen balls that are slow as from a spin time standpoint, you guys hear about the different levels for being faster or slower based on the asymmetry in the ball. I've seen balls as slow as 9 seconds, and that's definitely on the slower end. I don't have an intermediate differential measurement to go along with that, but I've seen it. And I've seen balls as quick as about 2 to 3 seconds. So, I mean, it does give you a pretty good resolution within that range.
And when we're
Yeah,
looking
I would say, we've seen, probably it's been a while, we've seen them over 10 seconds.
Yeah.
I don't know if Hank has some additional examples. We've done some stuff with Mo over the years. And when we say asymmetry, it's not, once you drill a symmetrical ball, now it's an asymmetrical ball. So it's more of
replacement.
Help me out a way to say this better. Measurement of the asymmetry, a strength of the asymmetry. Strength of the asymmetry maybe is a better way. That spin time is the strength of how asymmetrical that ball is. That's better.
I mean, we've seen them as slow as, like Nikki said, 9 to 10 seconds is probably as slow as we've ever seen them. Just based strictly on the speed of the machine and how fast. And sometimes the frictions of the covers make it come a little bit faster as well too. And we use a lot of high friction covers, so we tend to spend a little